So I've been working on the lathe a little bit, and here's some of the stuff that's happened. I have cleaned up and mounted my shunt wound motor controller. I have it mounted through here. Going back here, rewired the fan up that's underneath here. Rewired all this stuff already. All that should be good to go, hopefully. I have the one wire going to the communication to the Mach 4 and the Gecko 540 drive. I'll rewire in the potentiometer maybe later. Then on this end, and any German should look away, but if you're not German, I am starting to get the electric panel together. There's a transformer there to turn 220 into 110, so I can power everything from internal in the machine. And I'm just getting everything together off of the, this is 5 volt, 12 volt, 24 volt, all coming off the 220 to it. I gotta clean this up a little bit, but it's basically what we're gonna have. I'm going to wire up my next one of these heads in order to control the motor, and then hopefully I can start firing this thing up and I have control of all 3 axes and the motor, and then I'll start working on the limit switches. Alright, so I have been fighting this, and I've finally gotten to a result. This is the newest Mach. I had to download the newest Mach 4. I had to download the newest driver for the ESS, which is fine and reasonable, and Mach kind of pissed me off. It's hard to... The first time you do it, it's kind of hard to find where the newest Mach 4 is, but I found it. I found the one that correlates with everything. I got the correct plugin for the G540 drive, which is my Gecko drive, which is my motor control drive from the Warp 9 ESS. Worked out great there. I'm just using their setting stock. It made everything work. I'm as clean as I've been in here. We'll get it cleaner maybe, but not done yet, but fairly getting there. I'm pretty happy with this. I need to do some extra work in here eventually to put some manual controls in to be able to switch the spindle, but I have it running off Mach power right now. This I have running. I have the pendant working. In all 3 axes. That's Z, X, something sounds not great there right now, but we'll figure that out. And A. This is my tool change. I have 0 configurations done. I love this tool changer because it's you hear that click? So it's self-locking. So basically, when it does that, I know I'm ground out. Alright, get a phase it's not so yelly. And let me get the spindle going. So I gotta actually just put a code in here. MD, I don't know why it defaults to what the fuck. This little late touchscreen is getting a little hard for me. M3S 1000. Cycle start. It was working. Now it's not. Don't have power on. That's why. Whoops. Stop that. Braking works. That's 1000. Don't actually know if it's going 1000 yet, but I'll figure that out when I start tuning this. Let's bump this to 2,000. We get the speed increase. Sounds nice and clean, nice and stable. Let's bring it down to 500, let it break. Nice. Nothing's hot, everything's kind of working. I'm going to get this all buttoned up a little bit. I even have the fan running in there. Yeah, I'm pretty, Right, 1500. Not exactly sure what's making the rattling noise, but I'll figure that out as the time comes. Go for full speed. We'll break down for full speed. Awesome. Awesome, awesome, awesome. Yeah. So now I'm kind of back to where I was like 10 years ago last time I was really using this thing. I don't have the limit switch or anything like that put in yet because these are inductive switches, so it's like a proximity sensor, like a Hall effect setup. I don't know how to do that. I don't exactly know what power is. I think they draw power directly from the servo, so they're like, or the stepper, so it's like 36 volt, which is a lot of voltage to deal with this. And then this has a massive encoder ring, which I have to figure out as well to get RPMs and rip'ems and stuff so I can thread. But this thing should be a threading monster when I get it all set up correctly. But I think I'm going to make a code and run a stupid little part after I just button this up real quick. Everything's kind of wired in the way I want it. I just want to button it up so I don't shoot chips on it. But I think I'll run a code because laser a lot less scary than mills in my opinion on keeping it from crashing into things if you have your code run right. You just set your chuck to somewhere around here to be 0 and never go past it, and you're pretty much not going to hit the chuck, which is kind of the only thing you're going to hit and crash into with a lathe. You can crash into the part, but we'll figure that out. But yeah, I'll get some tooling. I still got to get the cabinet open down there to get the rest of my tool carriers out and all this stuff. And I can load up some tooling, and I'm going to try a quick little project on this just to see how she feels. But first I have to tune the motors. I'm going to do some research. Maybe I'll film some of that, but I don't know what I'm doing. So if I film it, it's not like it's going to be that informational to people maybe. I don't know. I'll see how it goes. Alright, so this is just the update with the lathe now. Oh, it's been a struggle to get this thing running, but I'm very happy that it is right now. Okay, so I'm dialing in the Z-axis right now. I got it pretty dialed in. I'll go over to this guy over here. Oop. Balls. Motors. I just made them all the same. But that is my counts per unit. This is a metric ball thread. I'm using inch units, so it's going to be a real weird number. But I just kept dialing in a little bit back and forth, a little bit back and forth. And now I'm just doing like 5,000 cycles just to see what it does. So, not bad. Let's go 2. Let's go 3. 4. So I'm going to go backwards now. Not bad. Like, that's pretty good. Now I'm going to send it 6 inches away, 6 inches and 2/10 away. That's how I determined that. I was sending it 6 inches away, which is the size of my 246 block. Can I do this one-handed without bumping anything? I might mess this up, but let's try. Now slide the block in here. And there we go. So, few tenths out with backlash at 6 inches is pretty good for the things I'm going to try to do with this. So I'm pretty happy with the Z travel. I can maybe dial that in later if I need to dial it in more for some reason, but I think that's more than accurate enough for what I'm doing. And next is going to be the X travel. And yeah, then I think I got to just see what this is actually spinning at per thing and see what I can do to adjust that, make sure that's accurate enough, and then I could try to run a part on this thing. Alright, so because I don't have the encoder wired in yet, and that's going to be a while, I have to pick like one speed that's going to be like the speed that works right. But I'm at like 2000 right now. I'm calling for, and it's like 2090, which isn't bad. I mean, you can't thread with that, but if I go to 1000, I let it break a little bit down. Let it settle in. I'm trying to tune in 1000 to be relatively the right number. I don't think I'm ever going to thread with this thing until I get the encoder running. But yeah, balls out. It's like 3400, and it's running pretty good. So braked. I got the X dialed in. The X was just double, so half, because it's twice the resolution as the Z-axis screw. So that was very simple. Just, you know, divide it by 0.5 or times it by 2. And that was balls on, exactly what I needed it to be, which is great. So X is in. That's basically dialed into 1000 RPMs, 1000 RPMs is pretty true. I would need to put the encoder on it to be more true on that one. And yeah, let me build a quick code, and I'll get a cutting bit in and let me cut something that I want to cut. Alright, so I'm just going to face this off real quick. I put in a cutting tool. Bearings right. I'm going to face this, zero it. I have to dial this tool in. This tool looks low. That's unfortunate. So let me... Okay, that could be okay. Just gonna face it at 1000 RPMs. So that didn't work. That just popped my axis all the way down. Okay, so I gotta try a different tool. I gotta try a different tool that's a little higher, or I gotta I can adjust that. Okay, so I can adjust that. I'm going to bring A. Make sure it's hitting against there. Jump close to center. Okay, let me move out so I can. Okay. So yeah, this is a piece of stainless, not ideal for my first test. I'm not really planning on doing too much stainless work, but the lathe should be able to handle it. Okay, let's try to take that bite. Nice. I'll set my Z0 now. Shoot through that really nice. Okay, so now we're going to okay. Okay. And I just want to see where we're at. .35805. 0.358. I'm going to ignore that .05, that 5 microns. to is 0.179. So I actually have my X dialed in now at 0.179. I know that's where I am radially, not diameter base, which is probably preferred, but I'm just going to make it easy on myself to start. I'm going to whip together a little code. I want to make a little piece, and I'll be right back with the code, and we'll try to run some G-code and see if we can cut this. So it's been a very long time since I made a G-code file. So we're going to give this one a shot. I'm going to, I backed it off. I'm going to cut air to start, just to see how it goes. And if it goes good, then I'm going to try to cut this. Alright, got you guys in frame. Let's cycle start the code. Okay, that looked fairly okay. Let me reset a 0. Okay, if I re-zero my Z, here's shit in my eye. A little too fast. I think my feed rate was a bit too fast, but it definitely cut it. Let me drop my feed rate down, because that's really sending it. And let me try it again. I don't think I destroyed the bit, maybe. Alright, so I brought the code into being a third of the speed, so 5 inches per minute. That seems more reasonable. Okay. Gotta work on my chamfers a little bit, but there's the part. And, well, it's an LCD button in stainless, kind of. I want this to be 114. And they're supposed to be 0.122 range. Okay, so I'm within 0.2 there, or 2 thou. And then I think it's supposed to be 0.14 the whole thing. Okay. A little bit of tweaking still needed. But I did set that up to be, basically set it back up there. So you do this, you'd bump the stock against it, and then you could run a cycle again, it'll pull back face it, cut everything it needs to cut, and then keep going. I'll tune this in if I care, but I'm not actually planning on making stainless steel LCD buttons. I just had something I needed to model quick that I could do with one tool very easily, and it's small and a fairly simple geometric part. So I didn't think about it fully. I had to cut the chamfers down a little bit and work on my cut at the back there. I would probably slow it down a lot more getting in there, just to try to get rid of some of this burr. But the lathe is running. This Andrew at FloryPB, the lathe is running. Not perfect yet, but we are moving. Alright guys, that's it for this one. Thank you.